Hello everyone, FunshineX here. Welcome back to ComputerCraft tutorials for Minecraft 1.6. Before we get started, there's just one thing I gotta do. Hooray! 10,000 subs! My channel just crossed 10,000 subs, and I'm just blown away. Never thought I'd get here, so it's a big deal, big day, exciting time. I figured I better put out another ComputerCraft tutorial because so many people have been begging me for them and frankly getting quite mad that I haven't put out one in quite a while. They're looking at my old ones going, where are the new ones? Because these ones don't work anymore. And that's correct. So today we're going to do another ComputerCraft tutorial. This is for Minecraft 1.6.2, and it's also using ComputerCraft version 1.62. Very convenient. And today is tutorial 7, which covers modems. So let's get started with modems. I'm going to have to go ahead and kill this program here. And if you want that code for the 10,000 program, it's going to be on my forums. The first thing I want to do is attach a wireless modem to this computer. I'm a little bit in trouble doing this, though, because I've got the monitor on the top. I've got my printer on the left, got my disk drive on the right. Underneath, it's detecting redstone for my door signal. On the back, it's detecting redstone for my lights. So I'm kind of stuck. I don't really have, I guess I could put it on the front, but that's kind of ugly, right? So let's do something first, and that's actually going to use a wired modem. And what I want to do, let's get a printer and steal this paper and the dandelion and go and break that guy. Oop, we can see outside. And then over here, nothing in the disk drive, so let's just store a copy of it and break him. If I put a wired modem right there and run a little bit of networking cable here and here, and let's see, let's get rid of this chest. So actually, let's run the cable here and here. I'm going to put my disk drive there and my printer there. And I'll probably need to go outside to set this. Other wired modems on the peripherals themselves. There and there. There we go. So now these peripherals are connected to my computer just as if they were right next to it. I do have to do one more thing, though, is right-click on this guy so he turns red. And you can see he was given a name called computer_1. That's important. This one is going to be drive 0 and printer 0. Okay, so we can go ahead and clean this up. There we go. Go back inside. Alright, so what we need to do now to be able to make sure we can access our printer and our disk drive, let's go and put the floppy disk in here. And let's do a directory. Do we see a disk? We still see a disk here. So we didn't have to do anything, it just automatically knows that there's a disk here. And I can do a cd disk. And let's got boot up and startup. Let's do oh goodness, label. It's a label set. Now we've got to do the drive, but remember the drive is no longer the direction, left, right, up, down, whatever. It's actually on a cable. And we called it, if you remember, drive_0. So if I go drive_0 and I call it floppy1, let's look at this now. It's called floppy1. So basically, just when you have these wired modems, you replace the side with the actual name of the peripheral that was assigned when you turned that modem on. So we could do the same thing with our printer, just when we output to our printer, instead of saying to the west or left or whatever we had before, I think it was left, we would say printer 0 as the direction. So that basically gives you an infinite number of sides. Well, not really infinite, but you can just run networking cable to a bunch of monitors or peripherals and easily not have to connect all of them to this side of this computer. So now I'm free to shift-click on that computer to add a wireless modem. The wireless modem, you can't just right-click to turn on and off like we did with the wired modems. We need to actually write some code. So let's go into Lua mode and write some code. If we take a look at the Modem API on the ComputerCraft forums or ComputerCraft wiki, we've got a number of functions for the Modem API, but we need to wrap it first. You can't just call modem.whatever. So we need to say modem is equal to peripheral wrap, and we are on the right side, of the monitor. Okay, or of the computer. Now we can check and say modem is open, and that's just like a question. And we need to actually say a channel number. So let's check channel number 0. Is that open? It's not. Well, let's open it. Modem.open channel 0. Okay, now we test and see if it's open. True. All right, so you can see now the modem is turned on because it's got this little red band around it. So you know it's listening on a channel, but now you need to test to see which channel's open. So you kind of have to remember which ones you do open in your code, but you can always test if they're still open. If we want to close it, stop listening on that channel, we can just do close. And now it's closed. We can test if it's open. It's not open anymore. Okay, there's another one. If we do like modem.open channel 0 and channel 1 and channel 2, you can see we're now basically we're open. And let me describe what that means. Basically, that means this modem is now kind of in a listen mode, and it can receive, if there's a modem around it within 64 blocks that transmits a signal on that channel, it would receive it and be able to have an event fire when it receives the message. So that's all we're talking about when we say a channel. So now I've opened channel 0, 1, and 2. I'm listening, waiting for messages on those channels. But if I want to close them all, I can do close all. And that will close all the channels at once. There's another test we could do and say, modem, are you a wireless modem? Just checking. It is. If we do modem 2 equals peripheral.wrap left, modem 2 is wireless. Are you wireless? You are not. Okay, so that's how you can tell if the side of the monitor, of the, I keep saying monitor, but it's the actual computer, the advanced computer or normal computer, is wired or wireless. And you can see now we've closed all this, is now a black band. So let's go ahead and open it up again. As far as channels, you can go up to, let me see, 65,535 channels. So that's pretty cool. Let's open that one. That's our high channel. And you can also open, your lowest one is 0, as we showed before. And you can have a total of 100 channels open per modem. So this guy here can listen to 100 channels at once. That's pretty crazy. Next, what do we need to do? Well, now we need to actually submit a message on one of these channels so it can receive it. Well, let's do a little bit of a code instead of just doing the Lua editor. So let's get out of the disk. Oh, come on. Back to just the standard ROM. And let's edit a program called modem receive. Okay, and in this one we're going to do modem dot open, let's say open channel 0. Then we're going to do wait for event. So all we need to do is say, oops, we got to wrap the peripheral first. So modem equals peripheral dot wrap right, and then open channel 0. There's no harm in opening a channel that's already open. It doesn't do anything bad. And now let's do an event. The event name, that's going to do well, we're going to do OS pull event. So let's write that first. And we want the type of message called modem underscore message. All right. And that one gives back as parameters. The event name is the first parameter. Second parameter is called modem side. So that's which side the modem that received it came in on, because you might be listening for modem messages on multiple sides. I don't know if you'd ever use that, but it's fine. Modem side is the first parameter or second parameter. The next one is the sender channel. So this is if another computer sends the message on channel 3, it would be, or I wouldn't receive it. If it was channel 0, it would receive it, and the sender channel would be set to 0, right? And then reply channel is sent by the sender, and he says, well, I'm sending out a message on signal 0, channel 0, but I want you to reply back on channel 3. That's all I'm going to listen to. You could do something like that. Normally the standard is just to send and receive on the same channel, but that's is configurable. We can do the actual message that was sent over the modem and how far away the sender was from this receiver. And that is equal to OSPOVA. Alright, so that's all the messages we're going to get. And now let's just go ahead and say print out a message, and let's say I received a message. And we'll just put the message here. Let's see, we want to put something on channel dot sender channel. Okay, and then we'll put the message, and that should be it. Let's see if this runs without error. Looks like it's good. All right, now we need to actually send it a message. So let's get another computer. Let's just put it over here. Get a modem and put it on top this time. We can do this from the Lua window. So let's do modem equals, oops, that's not an equal sign. Peripheral.wrap, wrap the top. Oh, I'm having horrible typing issues. There we go. Oh man, that was bad. Wrap the top, modem.open channel 0. All right, now how do we actually send a message? We know how to listen to it, but now we say, well, actually, we don't even have to open. We can just say modem. Let's close it all. I'll show you that this works. So the modem is off, it's black, and we say modem.transmit. Transmit a signal. First parameter I want to provide is what channel to send it on. So I'm going to send it on channel 0. The next one is what I want them to reply on. I'll say reply to me on channel 1. Sure. And then the actual message that we want to send. Sending out an SOS. There we go. And we'll hit go. And it did something, right? It went woo through the sky. Did you get the message? I received a message on channel 0. Unfortunately, there's no actual message. Did I do that wrong? I think I have a typo here. Oh, I used shorthand, and it was actually a long thing. There we go. So let's do that again. Modem receive. Over here, let's send the message again. And there we go. Sending out an SOS. Cool. And he was received it on channel 0. If we investigated the other parameters, we could know that he wanted us to reply on channel 1. Cool. That's awesome. Is that all we can do? No, that's not all we can do. We can do quite a bit more. I want to talk a little bit more about some wired modems and a little bit more on the Rednet messaging system. So give me just a second to set all that up, and we'll continue with the tutorial. Okay guys, it's time to show you all the ways that your computers can talk to each other. Here I've got 2 computers with wireless modems on top, and 2 computers each with a wired modem connected via network cable. I've also got a turtle, which I haven't shown you guys, but you probably know what they do if you've seen ComputerCraft before. And he is a wireless modem on the side of him as well. So let's start with the wired modems over here. And first, remember, I need to enable them. So connect the Rednet cable on both sides. Okay, so now the cable is connected to the modem itself. And now we need to go to each computer, and I'm just not going to write a program. I'm just going to go into the Lua interactive prompt, and I'm going to open that side. So on the Rednet API, I'm going to do an open, and this was on the right side of the computer. Oops, help if I put a bracket there instead of a 0. And you can see now that's got that red ring around it telling you the modem is open. And this one's the same one, but I just need to open the top. I'm having troubles typing today. There we go. So now they are both modems are on, and the network cable is connected to both modems. We should be able to talk to each other. So there's a couple ways you can do that. The first way is just to we have to actually tell them that we want to receive a message. So I'm going to say receive, and if I just do it like that, the program's just going to stop and wait forever for a message to come in. Okay, and then over here I can do a rednet.broadcast, and this will send a message on all Rednet channels to anyone that's listening. So I said hello, and now if we come back to this guy that was listening, you can see he got the message, hello. The 12 is the ID of the computer that sent it. So it's not the computer's name, it's not the string you give it a label or whatever, it's actual ID of the computer. And really that's just determined by the order the computer was placed into the world. So this basically meant computer 12 sent me the message hello. And it was working. We're not listening to any channels here, specific IDs. We're just saying, you know, because we're on the LAN cable, any computer that's also on the LAN cable can talk to each other. So the other way when we're receiving, actually I'm going to do it on this guy, is we can give it a timeout value. So let's say we only want to wait for like 10 seconds. We can just put 10, and he's going to sit here for 10 seconds. And if nothing comes through, let's count to 10 here, that call should just end and say, you know, nothing came in. So now it's not raining anymore. So it would not get a message. So let's do that rednet receive, and let's do the blocking version again. So it's just waiting forever. And over here, I want to do a rednet. Instead of broadcasting, I want to target a particular computer. So instead of doing broadcast, I do send. Now I need to type the ID of the computer, which is easy to know because it just told us what its ID was, 12. And let's say hello back. And we should have got that message here, hello back, and the ID of that computer was 11. If we receive here, and this guy over here sends it to 13, nothing happened here. He did not get that message because that was only meant for computer 13. He ignored it. Okay? This is not, you know, like there's no way to like secure this and say only send it to a specific machine. Anyone, or only listen to a specific machine. Anyone that could listen to a broadcast could see it and that kind of thing. So just if you're playing for fun or whatever, then keep track of how secure your messages are, or they might get intercepted. Okay, so that's LAN cable. Let's do the same thing with wireless modems. You're going to see it's almost exactly the same. So let's do rednet.open, and let's open the top. On that one, you can see it's got the red light. Same thing on here. Red light there as well. Now let's do the same thing. So this guy's just going to receive a message. And let's go ahead and broadcast. Actually, let's do this as well. Oops, you can do Control-T to terminate out of that. And actually, I wanted that to list in there. Oops, never mind. So rednet.broadcast. Hello wireless. I don't know. And you can see this computer, since he has a wireless modem and he was listening, and you can see I'm opened on the right and I'm opened on the top, so I didn't have to specify which modem I was waiting for. Just, you know, any rednet message on the sides that I'm open. And he got the message from computer 10, hello wirelessly. This guy over here, he's still waiting because he does not have a wireless modem. He does not know anything about that message. Pretty cool. And we can do the same thing. We can send messages back and do all that kind of stuff. There's an additional API method in 1.6 where you can host protocols. And that's a little bit more complicated, but let's do it on the wired ones. If I do a, let's 10 out of this, rednet.receive, and if I put a string here, and I can just call this anything, let's say this is the Ron IP, I don't know, the Ron's Internet Protocol, and then I can just say listen forever. And now it's only going to listen for that protocol message to come through. So I can do rednet.broadcast. Hello? And let's see if it got it. It did not get it because it's only looking for that certain protocol. So to do that, I need to broadcast on that protocol, which is pretty easy. It comes after the message, so I can do hello and then do Ron IP. Oops. And now he should have got the message. There you go. So now it gave us a little bit of extra data. It said, computer 11, send us the message hello on the protocol Ron IP. So that's a way you can actually filter and secure your messages, giving them that protocol value. You'd have to know on both the sender and the receiver the secret code or whatever you want to call it. This can also be you can make something into a host. So let's do that. Let's make this guy the host. We're going to do rednet.host, and he's going to specify the protocol. Let's do Ron IP again. And he's also going to provide a host name. So let's just say Funshine 1. That could be an IP address. It could be whatever if you want to think in the real world. I'm just going to call him Funshine name. Funshine 1 is his host name. Okay. And now he's hosting on that network. It's just basically told everything on the network. I'm the host of this IP address. I'm available, whatever. I can always unhost if I want to, just by doing unhost and then just typing the protocol and the host name. Same thing, but let's just leave it hosted. Now, if I come over here and I want to find out if a protocol exists and where that computer is, what its ID number is, that kind of thing, because I don't know, even though he sent me his ID 11, maybe I've never received a message from him before, and I can just do rednet.lookup, and I'm going to look up that Ron IP protocol and the host name. And look, it tells us, well, there's one computer on this protocol with that host name as ID 11. Okay, let's do the same thing over here. Rednet.host. And we'll do the same thing. So Ron IP and Funshine 1. Oh, the host name is already in use. Okay, well, let's do Funshine 2. Alright, and now we can do over here that rednet.lookup. Same protocol, but a different host, right? And that was ID 10. So that's basically a way to, if you want to create a program that can run arbitrarily anywhere and you don't want to know the IDs of a computer, you can assign them a protocol and a host name, and then it doesn't matter what their ID is, just as long as they're on the network, they can talk to each other. So that's a lot easier than trying to figure out what's your ID. Oh, okay, now I know ID, I gotta store it and all that kind of stuff. Just look up, just host and then do a lookup. That's pretty easy. Alright guys, so for the next test I've added a third computer with the modem on the bottom. Here I've opened the modem and I've given him the IP of Ron IP and the host name Funshine 3. And that registered him on the network, so nobody else could use that IP protocol and host name. And then if we come over here, and you can see I'll do a rednet lookup, and I can look up the IP address and a host name, or I can just look up the protocol. Sorry, not IP address, the protocol Ron IP, and that will give me all the computers on the network with that protocol, no matter what their host name is. So now I can see there's actually 2 computers there, and I can actually host. Let's do a host here on Ron IP. Alright, he's 4. And if I look up now, we should have 3 computers on that protocol. There we go. 12, 11, 12, and 13 are all on that protocol. And you can do the same thing. What if I don't care about the protocol? Actually, I have to give it a protocol. I can't just say a host name. That wouldn't make any sense. Okay, so that's pretty much it for communicating. Just know that a turtle is the exact same way. It has a Lua prompt. We can do rednet.open. It's actually going to be his left. It's the way he's facing. So he's facing this direction. So in a monitor, it's as you're looking at the monitor. So that's on the right. And the turtle, it's the way the turtle is looking. So that's on the left. Just a little change between the different things. But I can rednet.receive. And then broadcast from somewhere else that's got a wireless modem. Oops. And he should get that message. What's cool about it is if I make this guy receive and this guy receive, I've still got it in there, and I don't specify a protocol, right? And then I broadcast from here. It's actually going to broadcast on both the wireless network and the wired network. So he's going to get the message, and he should get the message. Pretty cool. So that might be another reason you want to specify a protocol, is maybe the wired modem might use one protocol and your wireless between your computers uses a second protocol, and then your messages going out to your turtles uses a third protocol. Just ways so you can specify how you're sending those messages, who you want to receive them. Because that way you don't have to send one message to this turtle ID 14 or whatever. You can just send it to all of your turtles. Maybe you have a whole army of turtles and you want them all to dig, right? Then you can just send one message in on a certain protocol and they can all listen. So that is really cool. Guys, that's going to do it for modems for ComputerCraft 1.6. Put a comment down below if you didn't understand anything or if there's anything I missed. If you have any ideas for future tutorials, let me know. What do you guys need me to understand? We definitely need to cover turtles, right? And a few other things that have been added into ComputerCraft in 1.62, 1.63 we need to upgrade. And right around the corner is going to be the 1.7 port of ComputerCraft if it's not out already when you're viewing this. Hit that like button if you enjoyed the video, and hit the subscribe button if you want to see more ComputerCraft tutorials. This has been FunshineX for ComputerCraft tutorials for 1.6. See you guys later. Bye.